In today's lesson, we're going to learn how to graph quadratic functions of the form f of x is equal to ax squared plus bx plus c. We'll start off with some crucial terminology. A quadratic function means that your function has to have an x squared term, and it will have nothing higher than an x squared, so it will not have any x cubes, for example, or x to the fourths. Anytime we graph a quadratic function, we're going to get a U-shaped graph like you see here. The U-shaped graph of a quadratic function is called a parabola. The vertex of a parabola is the maximum or minimum point. And whether it's a maximum or minimum will depend on which direction your parabola is facing. If you have an upward facing parabola like this, your vertex will be the minimum point. If you have a downward facing parabola, like we see here, your vertex will be the maximum point. The axis of symmetry of a parabola is a vertical line that divides the parabola into two equal halves. If we look at our two parabolas above, the axis of symmetry for this parabola is this dotted line right here, and we often draw an axis of symmetry as a dotted line. And the axis of symmetry for this parabola over here is this orange dotted line right here. Notice also the axis of symmetry always passes through the vertex of the parabola. We can see this axis of symmetry passes through the vertex right here, and this axis of symmetry passes through the vertex right here. Now notice when we're graphing quadratic functions, the parabolas can either open up or open down. And just by looking at your given quadratic function, you'll be able to know whether your parabola opens up or down. To determine if your parabola opens up or down, you'll want to look at the a, which is the coefficient of your x squared term. If your a is a positive value, in other words, a is greater than 0, then your parabola will open up, like this one. If your a is negative, or in other words, less than 0, then your parabola will open down like this one here. Now we will be given quadratic functions of this form here, and we will be asked to graph them. In order to graph them, I recommend that you follow steps A through F shown here. I'm going to first just go through how to complete steps A through F, and then after that, we'll go through several examples together. If you're given a quadratic function and you're asked to graph it, first step A, we're going to determine whether our parabola opens up or opens down. As we said on the previous page, all you need to do is look at the coefficient of your x squared term, the a. If your a is positive, or in other words, greater than 0, your parabola will open up. If, on the other hand, your a is negative, in other words, less than 0, your parabola will open down. Once you've determined if your parabola opens up or down, we'll move on to step B, where we find the x and y coordinates of the vertex. We start off by finding the x coordinate of the vertex, and we can find the x coordinate of the vertex of any quadratic function by simply computing the opposite of b over 2a, where a is the coefficient of our x squared term and b is the coefficient of the x term. Once we compute the x coordinate of the vertex, we can find the y coordinate of the vertex simply by plugging the x coordinate of the vertex into the function and then solving for f of x. Once we find the vertex, we'll want to find the equation for the axis of symmetry, and this is actually very quick to do once you've computed the vertex. The axis of symmetry is a vertical line with the equation x equals, and it's going to be equal to whatever the x coordinate of your vertex is, which in this case we're representing it as opposite of b divided by 2a. And again, for now we're just writing down the instructions. We'll see an actual example very shortly. Next, we're going to find the y-intercept. In general, in any math problem, if you want to find the y-intercept, all you need to do is plug in 0 for x and then solve for y. Or in this case, we're using f of x instead of y. So we'll solve for f of x. We're going to come back to this shortcut very soon. Step E, we're going to find the x-intercepts. And in general, in any math problem, if you're trying to find the x-intercept, all you need to do is plug in 0 for y. Now, instead of y, we're using the notation f of x. So I'm going to write plug in 0 for f of x. And then once we've plugged in 0 for f of x, then we go ahead and solve for x. And in order to solve for x, we're going to do this by factoring or by using the quadratic formula. And we'll see examples of all of this very shortly. Once we've completed steps A through E, then we'll be able to sketch a good graph of our function. Let's try example number 1 together. We're going to take a look at this given function here, and we're going to complete steps A through E in order to help us graph this function. First step A, I'm going to just start by copying this function down. For part A, we want to determine if our parabola is going to open up or down. All we need to do is look at the coefficient of the x squared term. And the coefficient of this x squared term is an implied 1. We call this coefficient A, and since this is positive, we can say that A is greater than 0. We said on the previous page that if our A, our coefficient of our x squared, is greater than 0, then our parabola will open up. That means our parabola will be an upward-facing U like this. Next, we want to find the coordinates of the vertex. When we're looking for the coordinates of the vertex for our parabola, we always start with the x-coordinate. And to find the x-coordinate, we're going to use the formula the opposite of b divided by 2a. So let's see. b is negative 2, so the opposite of b will be positive 2, divided by 2 times a, and we said a was 1. And if we take 2 divided by 2, that will leave us with 1. So the x-coordinate of our vertex is 1. Now that we have the x-coordinate of the vertex, now we can go ahead and find the y-coordinate of the vertex. To find the y-coordinate of the vertex, all we need to do is take the x-coordinate, which we've just found, and plug it into our given function, which I've copied down right here. So we've plugged our x-coordinate into the function, and that will leave us with 1 squared gives us 1, minus 2 minus 8, and that will leave us with negative 9. So now we found our x and our y coordinate of our vertex. Let's now go ahead and write our vertex. Our x coordinate was 1 and our y coordinate was negative 9. It can be useful also to know if the vertex is a maximum or a minimum point. Since we determined that our parabola opens up, the vertex will be right here, and we can see the vertex will be a minimum point. Next step, we're going to write the equation for the axis of symmetry. Once you've found the vertex, you'll be able to find the axis of symmetry very quickly. But before I show you the real quick shortcut, I'm going to show you an explanation first. So let's go ahead and draw a real rough sketch of our parabola so far. All that we know so far is the vertex and that our parabola opens up. So our vertex is at the point 1, negative 9. So here's our vertex or our minimum point, and we know that our parabola opens up. So just a real rough sketch would look like this. And at this point, we don't know the x-intercepts or the y-intercepts, so I'm just drawing a real rough estimate of our sketch right now. Now the axis of symmetry is a vertical line that divides the parabola in half. As we said on the previous page, the axis of symmetry always runs through the vertex. So our axis of symmetry will look like this. And our axis of symmetry is a vertical line. If you remember, the equation for a vertical line is always x equals. And to write the equation for this vertical line, we're going to write x equals 1, since it crosses the x-axis at 1. Now notice, instead of drawing a rough sketch here, we could have used a shortcut to find our axis of symmetry. The axis of symmetry is a vertical line, and any vertical line has the equation x equals. And to figure out what number to put here, you're just going to want to look at the x-coordinate of your vertex, which was 1 in this case. So our axis of symmetry will be x equals 1. If the vertex had an x-coordinate of 10, then your axis of symmetry would be x equals 10. If your vertex had an x-coordinate of negative 19, then your axis of symmetry would be x equals negative 19. Next step, we want to find the y-intercept. And let's look back at our notes briefly. We said that to find the y-intercept, we plug in 0 for x and then solve for f of x. So I'm going to start by just copying down our given function, and let's go ahead and plug in 0 for x. This will leave us with 0 minus 8, which will leave us with negative 8. So if we write our y-intercept as an ordered pair, the x-coordinate of any y-intercept is always 0. That's why we plugged in 0 for x. And then we found that the y-coordinate, or in other words, the f of x coordinate, is negative 8. Now, there is a shortcut to find the y-intercept. Notice the y-intercept always has 0 for your x-coordinate. To find the y-coordinate, all you have to do is look at the constant in your original given function. So this constant was -8, so we put -8 for our y value. This makes sense because when you plug in 0 for x, this will equal 0 and this will equal 0, and all you'll be left with is just the constant. So let's turn back to the previous page for just a minute to fill out that shortcut. So for the y-intercept, the shortcut to find the y-intercept is that the y-intercept always has the x-coordinate 0, and the y-coordinate is always the constant c. Next step, we're going to find the x-intercepts, and let's look back at our notes to see how we find the x-intercepts. To find the x-intercepts in any math problem, we always plug in 0 for y, or another way to state that is we're plugging in 0 for f of x. After we've plugged in 0 for f of x, then we go ahead and solve for x. Now, when you're finding the x-intercepts of a quadratic function, in order to solve for x, you're going to either need to factor or use the quadratic formula. And I'm going to start by just copying down the function that was given to us on the previous page. So in order to find the x-intercepts, we're plugging in 0 for f of x. Now, we've discussed 3 different ways we can solve this. Sometimes quadratic functions can be factored. The 2 methods that always work to solve quadratic functions are to complete the square or to use the quadratic formula. Generally, most people prefer using the quadratic formula instead of completing the square, so we're going to discuss 2 methods here, either factoring or using the quadratic formula. Let's start off by seeing if we can solve this by factoring. In order to factor this quadratic function, we'd like it in standard form. And while this is fine, it's more common for standard form to have 0 on the right side, so I'm just going to rewrite this as x squared minus 2x minus 8 is equal to 0. Now it's officially in standard form. Now we need to find 2 numbers that multiply to give us -8, and we need those same 2 numbers to add to give us a -2. And the 2 numbers that work there are -4 and +2. So we can now factor this. And then in order to solve this, we just set each factor equal to 0. And if we solve this, we'll be left with x is equal to 4. And if we solve this, we'll be left with x is equal to -2. I went over this fairly quickly, but if you'd like to review how to solve quadratic equations by factoring, look back at my chapter 4.8 video. Now, factoring is a great approach and it's often pretty quick, but not all quadratic trinomials can be factored. So it's good to be aware of method 2. The quadratic formula always works. Anytime you have a quadratic trinomial, you can always use the quadratic formula to solve. So let me just start off by writing our quadratic formula here for our reference. And I'll go over this fairly quickly, but if you'd like to review the quadratic formula, please look back at my chapter 7.2 video. We need to identify our a, our b, and our c, and then plug them into this formula. A is the coefficient of the x squared term, which is 1 in this case. B is the coefficient of the x term, which is -2 in this case. And c is the constant, which is -8. Now let's plug our a and our b and our c in for the a, b, and c's in the quadratic formula. Okay, now that we've plugged our a, our b, and our c into our quadratic formula here, now let's go ahead and simplify, and we'll start by simplifying underneath the radical. -2 squared gives us a +4, and -4 times 1 times -8 will give us a +32. And then we can write this all over 2 times 1, which gives us 2. And 4 plus 32 will give us 36, and the square root of 36 will simplify to 6. Now there's different ways we could simplify this, but to be consistent with the approaches we were using in the previous section, I'm going to use the splitting approach here. So to split this, I'm going to write this as x is equal to 2 divided by 2, plus or minus 6 divided by 2. And then we can simplify each of these fractions. So this will leave us with x is equal to 1 plus or minus 3. And now we can go ahead and compute our final 2 solutions. One solution will be 1 plus 3, which gives us 4. And the other solution will be 1 minus 3, which gives us a -2. Now notice we got the same answer whether we solved by factoring or used the quadratic formula. Factoring seemed to be a bit quicker here, but again, not all problems can be factored. Remember that we were finding the x-intercepts here, and we often like to write the x-intercepts as ordered pairs. So let's rewrite these final answers as ordered pairs. For any x-intercept, the y-coordinate is always 0. So I'm going to start by putting in 0 for the y-coordinate, and then one of the x-intercepts has an x-coordinate of 4, and then we have a second x-intercept. Again, we can write the y-coordinate as 0, and the x-coordinate for the second x-intercept is -2. So here's our final answer written in the form of an ordered pair. Now that we've completed steps A through E, now we have all of the information we need in order to construct a good graph of our function. I'm going to start by writing all of the crucial information that we found from steps A through E right here. Let's just look back quickly. We found that the vertex was the ordered pair 1, -9. We found that the axis of symmetry was x equals 1. We found that the y-intercept had the ordered pair 0, -8. And we found these two x-intercepts. So I've just written all of that crucial information right here. I'm also going to add that we noticed that our parabola opened up. So our parabola will be facing in this direction. Let's start by drawing our vertex at the ordered pair 1, -9. This is my abbreviation for the axis of symmetry, and we found that the axis of symmetry is the vertical line x equals 1, so let's draw that in. Next, let's draw our y-intercept, which we found was 0, -8. And then let's draw in the two x-intercepts. Now these are all of the key points that you want to make sure to include on your graph, but we can use symmetry to obtain one extra optional point if we'd like to help make our graph even more accurate. To find the one extra point, look at your y-intercept. Notice that the y-intercept is 1 unit to the left of the axis of symmetry, so using symmetry, we can go 1 unit to the right of the axis of symmetry to draw one extra point. And let's see, that point has the coordinates 2, -9. Now that we've got our points, I'm going to start at the vertex right here. Notice that is the bottom of our U, and our U is going to curve up from there. So I'm going to draw our U curving up from the vertex, and we want to make sure that it goes through the y-intercept and also through our x-intercepts. And there's a good sketch of our parabola. Lastly, let's determine the domain and the range of our parabola, and we're going to write our answers in interval notation. For the domain, you want to describe all of the x values on your graph. In interval notation, when we're describing the domain, we put the lowest x value on the left, and then we put a comma, and then we list our highest x value on the right. Now, our graph keeps going off and off and off to the left. That means our x values keep going off and off to the left, and as the x values go off to the left, they get more and more negative. So our x values are going to go off and off and off to -infinity. So we can see our lowest x value is -infinity, and a similar thing happens when we try to find the highest x value. If we look at our graph, the graph just keeps going off and off to the right. And if we look at our x values as we go off to the right, they get bigger and bigger and bigger and bigger. So our x values will just get bigger and bigger and bigger and bigger as they go off to the right. So our highest x value will be +infinity. Then with interval notation, next to negative or positive infinities, we always put parentheses. So we'll put a parenthesis here and a parenthesis here. And what makes it really easy is that the domain for every single parabola, whether it's a parabola that opens up or even if it's a parabola that opens down, the domain is always the same. It's always negative to positive infinity. So if you see a parabola and you're asked for the domain, you can right away put down negative to positive infinity. It's always the same. The range, though, will change depending on the problem. So for the range, if we're writing our answer in interval notation, we'll put a comma, and then we list the lowest y value on the left, and then on the right, we'll list the highest y value. So if we look at our graph, the y-axis runs up and down. So if we want to find the lowest y value, we want to find the point that's furthest down on our graph. That's this point here, and the corresponding y value is -9. So the lowest y value is -9. Then if we try to find the highest y value, well, we want to find the point that's furthest up on our graph, but our graph just keeps going up and up and up and up. So our highest y value will be +infinity. Then we just have to decide if we use parentheses or brackets with interval notation. If you see a infinity or negative infinity, we always use parentheses there. Now, with interval notation, parentheses mean that you're not including that endpoint. Since infinity is viewed as really being unreachable, we use parentheses because we can never actually reach or never actually include that endpoint. If you do want to include your endpoint, we use brackets. For the -9, that is an actual point on our graph, we want to include that in the range. So our final range will look like this. This tells us that the y values range from -9 all the way up to positive infinity. Let's take a look at another example here, and you'll see that these problems get much quicker with more practice. Again, we're going to be following the same steps in order to graph this function. First, step A, we want to determine if the parabola opens up or down. And I've started by just copying down our function right here. To determine if the parabola opens up or down, we look at A, which is the coefficient of your x squared term. If A is positive, your parabola opens up. If A is negative, your parabola opens down. Our A in this case is positive. In other words, A is greater than 0. So we can say that our parabola opens up. Next step, we want to find the vertex. In order to find the vertex of a parabola, we always start with the x-coordinate of the vertex. To find the x-coordinate of the vertex, we use the formula opposite of b over 2a. So let's see. b is -28, so the opposite of b will be positive 28, divided by 2 times a, and a is 4. And that will leave us with 28 over 8. That reduces to 7/2. So we found our x-coordinate of our vertex. Next step, we want to find the y-coordinate of our vertex. To find the y-coordinate, I'm going to start by just copying down our original given function. And to find the y-coordinate of the vertex, we're just going to plug our x-coordinate into our function. So I went ahead and plugged in 7/2 for x in our function. Now that we've done that, if we use our calculator to support us here, 4 times 7/2 squared will give us 49. -28 times 7/2 will give us a -98. And then we've got our plus 49. And if we take 49 minus 98 plus 49, we end up with 0. So we've now found the x and the y coordinate of our vertex. Let's write our vertexes in ordered pair. The x coordinate of our vertex was 7/2, and the y coordinate of our vertex was 0. And we'd also like to state here if the vertex is a maximum point or a minimum point. If we look up here, since we determined that our parabola opened up, that means our vertex is the bottom or the minimum point. Next, we want to write our equation for the axis of symmetry. We know that the axis of symmetry is a vertical line, and any vertical line has the equation x equals. And the shortcut to figure out what number you put right here, we just look at the x-coordinate of our vertex. And this is the equation for our axis of symmetry, x equals 7/2. Now let's find the y-intercept. I'm going to start by just copying down our original given function. If you want to find the y-intercept in any math problem, you can always plug in 0 for x. But we also talked about the shortcut. Let's start off with the x-coordinate of any y-intercept is always 0. And then to find the y-coordinate, the shortcut is we can just look at the constant, which is 49 in this case. So the y-coordinate of our y-intercept is 49. Okay, let's take a look at the next page. Step E, we want to find the x-intercepts. To find the x-intercepts, we always plug in 0 for f of x and then solve for x. I've started off by just copying the given function from the previous page. Now in order to find the x-intercepts, we plug in 0 for f of x. Now we could factor here. This expression is factorable, so factoring will give us the x-intercepts here, or we could use the quadratic formula. You can pick whichever approach you prefer, but I'm going to demonstrate the quadratic formula. To use the quadratic formula, we have to identify our a, our b, and our c. A is going to be 4, b is -28, and c is 49. And I'm going to write the quadratic formula right here for our reference. So let's go ahead and plug in our a, our b, and our c into this quadratic formula. Okay, now that I've plugged in our a, our b, and our c, let's simplify underneath the radical here. -28 squared will give us 784. And then if we take -4 times 4 times 49, we'll get -784. And then we can write this all over 2 times 4, which will give us 8. Now notice 784 minus 784 gives us 0, so we're left with 0 underneath the square root. Now the square root of 0 is just 0, so adding or subtracting 0 does nothing, so we can really cross this off. And that just leaves us with x is equal to 28 over 8. That reduces to 7/2. Now we found the x-intercept, but we usually write x-intercepts as ordered pairs. So if we write our x-intercept as an ordered pair, we know that the y-coordinate of any x-intercept is 0, and the x-coordinate we found was 7/2. So in our previous example, we had 2 x-intercepts. Here's an example where we only have 1 x-intercept. Last step, let's go ahead and graph this. And in order to graph, I'm going to start by compiling all of the important information we gained from the previous 2 pages. Okay, we found that our parabola opens up. We found the vertex right here. We found the axis of symmetry, the y-intercept, and then we found our x-intercept right here. Okay, I've just copied all of that important information down here. And when we're graphing, it can sometimes be helpful to convert fractions to decimals, so I'm going to do just that. 7/2 is equal to 3.5, so we can write the vertex as 3.5, comma 0, and then we can write the axis of symmetry as x is equal to 3.5, and similarly we can write the x-intercept as 3.5, comma 0. Okay, let's start by plotting the vertex at 3.5, comma 0. Next, let's graph the axis of symmetry, which is the vertical line x equals 3.5. The y-intercept is at 0.49. And we have an interesting situation here with the x-intercept. The x-intercept in this particular graph is the same as the vertex. So we've already graphed our x-intercept when we graphed the vertex. For this particular case, our vertex lies right on the x-axis, so it's also an x-intercept. Now we've graphed all of these pieces. It can be helpful though to graph one extra optional point, and to get that extra optional point we use our y-intercept and we use symmetry. So let's see, our y-intercept is 1, 2, 3, 4, 5, 6, 7 units to the left of the axis of symmetry. So to plot one extra point, I'm going to go 7 units to the right of the axis of symmetry. 1, 2, 3, 4, 5, 6, 7. And that's the ordered pair 749. Now we know that our parabola opens up, so the vertex will be the bottom of our parabola. So this is the bottom and it will curve up from there. And then we'll just make sure to draw our parabola going up through the y-intercept and also going up through this additional extra point. Lastly, we need to state the domain and the range. We said in the previous problem that the domain for any parabola is negative to positive infinity, so we can fill that out right away. The range, though, will differ depending on your parabola. So let's see. For the range, we need to start by stating the lowest y value. The lowest point on our graph is right here, and the corresponding y value is 0. So our lowest y value is 0. Then we need to state our highest y value. Well, the graph keeps going up and up and up, so the y values keep going up and up and up, so our highest y value will be infinity. When using interval notation next to infinity, we always use a parenthesis. And since 0 is an actual point on our graph, we want to include it, so we'll draw a bracket. And let's take a look at one last quick example. First, we want to determine if the parabola opens up or down. So we look at our coefficient of our x squared term. That coefficient is negative, or in other words, less than 0. So we say that our parabola opens down. Next, we want to determine the vertex. When we're looking for the vertex of a quadratic function like this, we always start with the x-coordinate. To find the x-coordinate of our vertex, we use the formula the opposite of b divided by 2a, and let's calculate that. b is 8, so the opposite of b is negative 8. And then we divide by 2 times a, and a is negative 2. And let's see, that will leave us with negative 8 divided by negative 4. And negative 8 divided by negative 4 simplifies to a positive 2. So the x-coordinate of our vertex is 2. Next, we'll find the y-coordinate of our vertex. To start, I've just copied down our given function. Now, to find the y-coordinate, we just want to plug 2 in for x into our given function. And now we can go ahead and compute this. Negative 2 times 2 squared will give us a negative 8, plus 16, minus 11. And if we compute this, this will give us negative 3. So now we found the x and y coordinate of our vertex. The x coordinate is 2, and the y coordinate of our vertex is -3. And let's also check to see if our vertex is a maximum or a minimum point. Since we said our parabola opens down, that means the vertex is at the very top, or in other words, the maximum point. Next, let's find the equation for the axis of symmetry. The axis of symmetry is a vertical line, and any vertical line always has the equation x equals. And for the axis of symmetry, we always set x equal to the x coordinate of the vertex, 2 in this case. And lastly, let's find the y-intercept. And I've started by just copying the original given function. Let's write the y-intercept as an ordered pair. We know the x-coordinate of any y-intercept is always 0. And then for quadratic functions, the y-coordinate of your y-intercept is always the constant, which is -11 in this case. Now let's take a look at step E. Let's find the x-intercepts. To find the x-intercepts, we're going to plug in 0 for f of x and then solve for x. So I'll start by just copying down our given function from the previous page, and let's go ahead and plug in 0 for f of x. In order to solve something like this, we have two options. You can try to factor. Factoring sometimes works, but sometimes it doesn't. The method that always works for finding the x-intercepts is the quadratic formula. For this particular example, let's take a look at both methods. If we want to factor this quantity, we always start by first checking for a greatest common factor. The greatest common factor in this case is -1. So let's first start by factoring out the -1. Now that we've factored out the -1, in order to factor this trinomial, we need to find two numbers that multiply to give us 22, and we need those same two numbers to add to give us -8. You can try, but you'll see that there's no numbers that work here. This means that we can't factor. When you're looking for the x-intercepts, the only time you'll actually be able to factor is if your x-intercepts are nice whole numbers or fractions. If you're trying to find the x-intercepts by factoring and you notice that your trinomial is not factorable, that means that either your x-intercepts are irrational numbers, or that means that your quadratic function has no x-intercepts. In order to figure out which of those two cases it is, you want to use the quadratic formula. To start, I'm just going to write the quadratic formula here for our reference. Now let's identify our a, our b, and our c. A is -2, b is 8, and c is -11. Now let's go ahead and plug our a, our b, and our c into our quadratic formula. Now that we've plugged our a, our b, and our c into our quadratic formula, let's simplify underneath the radical. 8 squared will give us 64, and -4 times -2 times -11 will give us -88. So we'll write -88 all over 2 times -2, which gives us -4. Now if we take 64 minus 88, that gives us a -24. Now let's look carefully at the radical. We have the square root of a negative number. We know that the square root of a negative number is not a real number, it's an imaginary number. So if you're looking for the x-intercepts and you end up with an imaginary number, that means that this function has no x-intercepts. So there's no need to continue solving this quadratic formula. We were just using it to find the x-intercepts, and since we got an imaginary number, we know there are no x-intercepts. Now that we've completed steps A through E, let's go ahead and graph. I'll first start by writing the important information from steps A through E. If you look back at steps A through E, we found the vertex, the axis of symmetry, the y-intercept, and we found that there are no x-intercepts. Let's use this information to graph. We'll start with the vertex, which is at the point 2, -3. Now let's draw the axis of symmetry, which is a vertical line, x equals 2. The y-intercept is 0, -11. And there's no x-intercept. So it might be helpful here to have our extra optional point using symmetry. So to get our extra optional point, we always look at the y-intercept. Notice that the y-intercept is 1, 2 units to the left of the axis of symmetry. So to find our extra point, we can go 1, 2 units to the right of the axis of symmetry. And that gives us the ordered pair 4, -11. On the previous page, we said that our parabola opens down, so it will have this shape here, where the vertex is our maximum point. So let's start at our vertex right here. That's our maximum point. And then we just want to draw our parabola connecting down to the y-intercept, and then connecting down to this extra optional point. Now to determine the domain. The domain is the easy part because the domain for any parabola is always the same. It's always negative to positive infinity. And that makes sense because for the domain, you're explaining what the lowest and the highest x values are. Well, the graph keeps going off to the left, so the x values keep getting more and more negative, going off to negative infinity, and the graph keeps going off to the right, so the x values keep getting more and more positive as they go off towards positive infinity. Next, for the range, we're looking at the y values. We want to start with the lowest y value on the graph. Well, the graph just keeps going down and down and down. So the lowest y value will be negative infinity. And then we want to state the highest y value. It looks like this is the highest point on our graph, and the corresponding y value is negative 3. And we want to include negative 3 in our range because it's an actual point on our graph. So we use brackets to indicate that we're including that endpoint.